And welcome back. We are back learning Python. So just a quick note. I received a message from one of my recruiters. My recruiter told me that she's planning to propose me for a position regarding data warehousing. And she sent me a Percipio course about fundamentals of data warehousing. So what I'm going to do now is that I'm going to divert a little bit from the original plan. I'm going to dedicate one entire cycle. That's 4 Pomodoros. I'm going to dedicate 4 Pomodoros to learning Python and see how far can I get on the section 21, this one here, on the learning Python, machine learning, and data science, and see how far can I get. I'm going to dedicate 1 hour of my time to this, and after that's done, I'm going to move back to my private life, and I'm going to be learning data warehousing privately. Or maybe I should stream that. I don't know. I'm not too sure about that. But anyway, maybe I should stream that. Who knows? Maybe I can. You can learn something from that. Okay. Let's begin. Oh wait.
Course, machine learning. Now, throughout the course, we've learned that machines are really, really good at certain things. Machines can perform tasks really, really fast. And we learned through Python that we can control these machines and get them to do tasks for us. Now, these machines or computers are really good at things that we can describe, right? That we can write in code, if else blocks to do something. Computers are really good at working on tasks that have these defined rules, all the way up to a game of chess, right? When you play a game of chess against a computer, we could technically have if else blocks, lots of them, to see how to move each piece and what the pros and cons are. But then as soon as we stop having these specific rules, things start to break down. For example, what is a cat? If you could describe that to a computer, or you had to program in Python and try to write that code in Python, would you be able to? I mean, sure, you can say, hey, a cat has fur, a cat has whiskers, a cat meows. But then the computer asks you back, what is a meow? What is fur? The harder things become to describe, the harder it is for us to tell machines what to do. In this section, we're going to tackle this problem. And we tackle this problem using something called machine learning. And you've definitely heard of it because it is a big buzzword right now in our industry. Because with machine learning, you have so many applications. We could have self-driving cars, robots, vision processing, language processing, recommendation engines, translations, stock price predictions. There's so many applications. The goal of machine learning is to make machines act more and more like humans. Because the smarter they get, the more they help us humans accomplish our goals. Now in this section, we're going to go over some theory to get us familiar with this topic and then do 3 projects on both data science and machine learning to understand this topic a little bit more. Don't worry, don't get intimidated. We're going to try and simplify things and have fun along the way. Let's get started.
Okay. I know nothing about
At this
this.
point in the course, we've talked about Python careers, and we've talked about being a backend developer using Python, about testing and automation, about being a general Python developer and doing scripting, being a software engineer and just writing software using Python. But we haven't really touched on the subject of machine learning or research analyst, data scientist, data analyst. And you see, all these fields kind of overlap. So what is machine learning? When we talk about machine learning, you have to keep this diagram in mind. You see, it all starts with AI, or artificial intelligence, which simply means a human intelligence exhibited by machines. An AI is, well, a machine that acts like a human. And currently, in our industry, we have something called narrow AI. That is, machines can be just as good or even better than humans at a specific task. For example, detecting heart disease from images, or the game of Go, or even video games. But narrow AI that we have currently simply means those machines can only do one thing really well. They can't be like humans and have multiple abilities. That's called general AI, and it's something that we're very, very far away from. Now, machine learning is a subset of AI. And machine learning is an approach to try and achieve artificial intelligence through systems that can find patterns in a set of data. And actually, Stanford University describes machine learning as the science of getting computers to act without being explicitly programmed. That is, getting machines to do things without us specifically saying, do this, then do that, then do this. And don't worry, we'll explore that more throughout the section. Now, you may have also heard of deep learning. And deep learning, or deep neural networks, is just one of the techniques for implementing machine learning. For now, you can just think of it as a type of algorithm. But then we have this thing of data science. And often the role of a data science and a machine learning expert are quite overlapping. And most job descriptions actually don't even have a clear distinction between what is a machine learning expert and a data science expert. The field of data science simply means analyzing data, looking at data, and then doing something with it.
Maybe I'm going to be doing that in my next job.
Learning, there's a lot of overlap with data science. So throughout the next couple of videos, we're going to be talking about both of these topics because both of them relate and overlap. And you can't do one without the other because you need to be able to understand data and work with data to do any of these things. And that's why when we talk about careers, often things like machine learning, data scientist, data analyst, or research analyst are similar because they all work with data. And from that data, they want to derive some sort of an action for the business, for the company, or for the person. All right, that's enough for now. Let's move on to the next video.
Wait, I want to see that diagram, data science, okay.
All right, I know what you're thinking. You're thinking, Andre, I have no idea what you're talking about. What is machine learning? You haven't really told me anything. I have nothing to apply it to. Well, let's go back to this topic of machines and computers and the fact that they don't really understand words, right? If I ask my computer, hey, is this a snake? Is this a python? My computer's gonna, well, have no idea what I'm talking about. When I look at an image of a snake, no matter what color it is, no matter whether it's a cartoon or a real life image, or whether it has different directions with different animals in it, I can identify a snake right away. Our brains just know. But to tell my computer what a snake is almost impossible, right? Because there's so many factors. A snake doesn't have legs and arms, but an airplane doesn't have legs and arms. A snake has scales, but then the computer's gonna ask me, what are scales? But with machine learning, we can actually teach a computer to know what a snake is, or at least pretend like it knows. So how do we do this? Well, you remember this diagram, I hope. It's simply what we do in programming. That is, we give an input, let's say a list of 1, 3, we give it to a function, and there's an output of 2, 4, 6.
In this case, deterministic functions.
Items in our list by 2. And
But I guess this is not going to be the case.
Procedural. That is, we have if this, then that, do this, then this type of conditions. We tell the computer what to do. We write as programmers the input and the function. And all the computer does is actually just calculate using the input and the function, the output. And it can do that really, really fast for us instead of having a human do something when, let's say, a list is millions of items long. Machine learning changes this idea. It says, hey, give me the input and give me what you want the output to be. That is, give me all the data that you have. And by the way, tell me what the answer is, or at least what the output that you want. So in this case, I want the input to be a list of 1, 2, and 3, and the output to be a list of 2, 4, and 6. And then the interesting part is that as developers, we give this input and output, but with machine learning, we say, hey, machine, you figure out what this function is. Because if I give you, let's say, instead of a list of all these snake pictures, or maybe animals, and I want you to tell me if this image has a snake or not, or maybe these 100 images, which one of them has snakes, I don't know how to tell you how to do that. So instead, you figure it out yourself. Here are all the pictures, and here is what I expect the output to be, either snake or not snake. And with machine learning, the function is generated or created by the machine. Sounds really cool.
Yeah.
And this is machine learning. It's simply a function. So instead of us writing the function like we have before, with machine learning, the machine writes the function. We just give it the input and the output. And the word function can be replaced with a model. You might have heard of the word machine learning model. That's all a model is. It's a function that receives an input and returns an output. Another word might be algorithm, a machine learning algorithm, a machine learning bot. And at the end of the day, it's a brain. We're pretending that this machine is a brain that understands the inputs and gives us the desired output. Now, the interesting side effect of this is that often when we talk about machine learning models, these functions are really hard to understand. Because the computer comes up with this function, as a human, it's hard to really understand how it works.
Yeah.
As these models get more and more complex, it becomes harder and harder for us as developers to understand how it works, which raises a lot of issues. But we don't need to get into that. Now, as you can see, the main part of this is that in order to train this machine to create this function, we have to give it data. And for it to be really, really good, we have to give it lots and lots
A lot of data.
And then we want to test to make sure that this data that we give in gives us the correct output. So at the end of the day, machine learning is simply a computer writing its own function based on the inputs and outputs. That's pretty cool, isn't it? I'll see you in the next video. Bye-bye. One thing that I really like doing in my courses is to actually understand the why of everything. Everything that we learn, there should be a reason we're learning it, right? And you might be asking yourself, why do we even care about machine learning? How is that useful and how do we get here? Well, if you think about a business, because most technology evolves from business needs. We have the advent of computers and the ability for businesses to use computers to do things really, really fast and efficiently so that they gain an edge. And then we got spreadsheets. Spreadsheets like Excel files and CSV files were amazing because we can store data that businesses generate, such as maybe customer data, into an Excel file. And then people got really, really good at analyzing these CSV files, these spreadsheets, to make business decisions. Maybe forecasting that December sales are going to be high because, well, the past 2 years, we've had really high December sales because of Christmas. And then as companies got more and more data, we started getting this idea of relational databases. Spreadsheets were great, CSV files were great, but we started getting more and more information and data. And we needed a better way to organize things, to understand things from our data. That's when we got things like MySQL, which allowed us, instead of using spreadsheets, to use a language called SQL to read information from our database, write information to our database, but similar to spreadsheets, use the data that we gathered from the business to make business decisions so that our business becomes even more profitable. And then in 2000s, we had this fancy term of big data.
Big data.
We had big companies like Facebook, Amazon, Twitter, Google, that started accumulating more and more data. An insane amount of data that you simply couldn't contain in a spreadsheet. User actions, user likes, user purchasing histories. This idea of big data meant that we had so much data. These companies had so much data. And sometimes, unlike relational databases, which had to be a structured form of data, sometimes we got really messy, unstructured data. And that's when we started getting this idea of NoSQL, where things like MongoDB came into existence, where you can store unstructured data and hopefully make business decisions out of that. Maybe if you were Amazon, you can use customers' purchasing history to recommend different products. And ever since then, this idea of data, getting more and more data, has turned us into
That's
using
why it's
machine learning.
called big data,
Because at
because
some point,
it's
we have so much
so
data that
big.
we can't just look at spreadsheets and look at columns and rows and make business decisions. I mean, we still could, but then we'd be wasting all this data that we've been getting over the years. So companies like Facebook and Google that collect massive amounts of data every single day are turning to things like machine learning. So that instead of humans looking at the data and trying to figure things out, we give this data to machines so that they're better able, even better than humans, to make business decisions. This idea of machine learning really came to be because of growth in data that we received from businesses, as well as the improvements in CPUs, GPUs, that is graphical processing units, and computer advancements. So using the massive amounts of data and massive improvements in computation, we can use these machines to give them this big data and make a decision for us, just like we used to with spreadsheets. Now, this is a simplified version of how we got here, but I hope it gives you a reason as to why businesses like this idea of machine learning. I'll see you in the next video. Bye-bye.
Interesting.
Welcome back. Up until now, I've been blabbering on about what machine learning is, and I hope you have a bit of an idea of why we have it and why it's useful. But at the end of the day, the only reason that we care about machine learning is that we're able to use machines to predict results based on incoming data. That's it. Now, this idea of machine learning, and don't worry, I know we keep talking about theory, but I promise we're going to get some coding exercises first. But I do want to talk quickly about some of the machine learning categories that you often see. And keep in mind what I said. That is, machine learning is simply about predicting results based on incoming data. And all these subcategories simply do that. For example, we have the idea of a supervised learning, which is a subset of machine learning. In this supervised learning, the data that we received already has categories. Think of it as a CSV files with rows and columns labeled. We have labeled data and a test data that is labeled so we know if our function is right or wrong. So in a supervised learning scenario, we can do things like classification to decide, is this an apple or is this a pear? Machine learning model simply draws a line.
Supervised.
Hey, this is an apple and this is a pear. Or we might do something called regression instead of classification based on inputs. For example, predicting stock prices. Another way that we might use supervised learning is, for example, to hire engineers based on inputs, based on years of experience, based on maybe age, maybe where they live, what type of computers they have. All these sorts of inputs that are labeled can be used in a supervised learning system to decide, should I hire this engineer or should I not? Now, sometimes we have data that doesn't have labels, and this is called unsupervised learning. Again, think of it as a CSV file without perhaps the column names labeled. Sometimes with things like clustering, we need to create these groups, or at least the machine to create these groups. For example, we give it a bunch of data points and then the machine decides, oh, this is a group, and this is a group. Or we can have something like association rule learning, where we associate different things to predict what a customer perhaps might buy in the future. When groups don't exist, we call it unsupervised learning. We can't tell the machine that they are right or wrong, like we can when we do apples versus pears, since there are no true categories, but we let the machines just create these categories for us. Finally, we have this idea of reinforcement learning. And reinforcement learning is really interesting because it's all about teaching machines through trial and error, through rewards and punishment. So the program simply learns a game by playing it millions of times until, well, it gets the highest score. It doesn't know what it's doing at first, but then it tries to maximize the score and eventually figures out that, hey, maybe I should try and move where the ball is coming. So this is seen for skill acquisition or real-time learning. You see it a lot in machine learning programs that play, for example, video games. Now, I'll link to a resource so that you can dive into these topics more deeply, and we'll actually talk about this a little bit more and understand them a lot better once we go through some of the exercises. But the idea here is that machine learning has different categories and different ways to accomplish its goal. And topics like neural networks, decision trees, support vector machines, k-nearest neighbor are simply algorithms that are used with these
this is super
in order
advanced,
to come
actually.
to these predictions. But remember the key thing. All of these, what they're doing is trying to learn from the data that it receives and predict something. I'll see you in the next one. Bye-bye.
That's machine learning, learning from the data. Okay.
All right. I think it's time for us to actually start practicing some of these skills instead of just talking about theory. Because I know right now, everything looks super complicated. You think that to be a machine learning expert, you have to have a PhD and you have to be really, really smart with math and statistics. But often that's not really the case. So in this video, I want to show you what it actually means to do machine learning or data science. So in this machine learning 101, let's talk about what a machine learning expert does. The first thing that a person does is to usually import the data. That is, we have some sort of a CSV file, and we're going to import that data, and we know how to do that with Python, right? We import a CSV data file so that we can use it in our program. And don't worry, these are the steps that we're actually going to show you when we do our upcoming projects. So the first thing is to import the data. Next, what do? Well, we clean the data. That is, in an ideal world, we have perfect data. All the columns, all the rows of a CSV file are filled in, and everything is perfect. But that's often not the case. Sometimes you have missing labels. Sometimes you have missing cells or data. And sometimes we have just unusable data that's really, really bad. So we ideally clean the data so that when we use it later on, it's not going to give us any errors or make bad predictions. Now, number 3, what does a machine learning expert do? Well, we split the data. And this is an interesting one. We usually split the data into what we call a training set and a test set. What does this mean? Well, splitting the data simply means just deciding. We have, let's say, 100 rows of Excel, and we decide that the 80 rows are going to be our training set, what we give the machine to learn from, and then the last 20 rows are going to be the test set, because we have to tell the machine whether it got the answer right or wrong. So we need a way for us to test with our pre-existing data whether our model is good or bad. Again, this is something that we'll explore, but usually you split your data, your Excel sheet, into a training set, what we use as input, and then the test set, what we use to test the output that machine learning function gives us. And that's really easy to do. We just decide, hey, 80% of the data is going to be training set and 20% is the test set. Up until now, these 3 things are pretty easy, right? And as we'll see, they are quite easy. Next, is we create a model. All right, this one sounds really, really
That's a
hard.
function?
We just went from splitting data to all of a sudden we're creating this function, this model that our program creates. But the funny thing is that most likely what you do when you create a model is to import an algorithm. You're not going to write the algorithm from scratch yourself. Usually you use a library like Scikit Learn, which we're actually going to use to simply do an import and then decide what algorithm you want to use, like decision trees or k-nearest neighbor, and we'll actually see how to do that in an upcoming exercise. So that's really nice. Somebody has already built an algorithm for us that creates the model based on our training set. And the running joke is that when people think about machine learning expert, they think of all these mathematical equations that people do, but most of the time it's people just simply importing from a library an algorithm. That's it, a one-liner. Next.
Wow.
Well, we check the output.
Right?
We create the model, that is the function. We have the input, which is the training set, and then we check the output of this model with our test set. So the test set, we're going to say, hey, is the output matching what we expected? So once we check the output, what do? Well, we improve. So most likely the first time around, it's not going to get it completely right. So based on the test set, we say, hey, we can probably improve something. So as a machine learning expert, you might give it extra inputs, that is maybe an extra column in the Excel file, or we might want to change the model or the algorithm that you used to create this model. That's it. These are the 6 steps of what you do. And you just repeat these steps. Now we'll come back to these and I'll link to this in the resource so that you can always have it in the back of your mind. But right now, you just learned something really, really fundamental. You see, Facebook here, this is pretty much how they run their machine learning pipeline. And this diagram now should make sense just on those 6 steps that we talked about. We define our goals, that is, what do we want to accomplish? We gather the data, we parse the data, that is, we clean it, we split it into training data and testing data. We then do model creation and we experiment with different algorithms. And then we finally test our data, see how accurate it is based on our testing data. And then we just go back and try different things until our model or our function is in line with what we defined as a goal. Isn't that cool? You just learned how Facebook's machine learning structure works. Now, let me ask you one question before I end this video. What do you think the hardest part of this entire process is? I made it sound very, very easy, right?
The model.
Think about it. Ready for the answer? The hardest part is actually grabbing the data. Because the more data we have, the better. The more inputs we have, the more training sets we can have. So that we can improve the model. And yes, we can decide what algorithm to use to create a model, what inputs to use during the training set. But the more data we have, the more options we have as machine learning experts. And it's really tough to collect good data, or what we call data set. And companies like Google and Facebook are really, really valuable because they're the only ones
really
that
good
can collect
data sets.
And that's why machine learning is pioneered by these companies that have large sets of data. Because you and I just simply don't have enough data to really make machine learning worth it. Most companies don't actually need machine learning or can even implement good machine learning because they don't have enough data. You need big companies like Amazon to use machine learning because they're the only ones to have access to that data. And that's why they're so valuable. They can share their model, they don't care, but they usually keep their data private because that's what gives them a competitive advantage. Right? So now we know the steps of machine learning. The next is to learn what tools we can use to do these steps so that we can finally start learning and building our own machine learning models. I'll see you in the next one. Bye-bye. Welcome back. So up until now, we've learned the steps of machine learning and we learned the theory about machine learning. The last piece of the puzzle is what tools do we use in order to learn about machine learning so that we can finally start doing some exercises and projects. And this is why Python is actually one of the most popular languages when using machine learning, because Python has such a big community and it's such an easy expressive language, as we've learned, that it has a ton of libraries and modules that really help us do machine learning in a really fast, efficient way. It's not that Python is just the only language that you can do machine learning in. It's that Python has the best tools available currently to do machine learning. So what are these tools? The first one is NumPy. And NumPy is definitely a must when it comes to machine learning. It's a library that helps us to use lists and arrays in Python, and specifically multi-dimensional arrays, which are used very, very often in machine learning. So we're going to be using NumPy. And then the next one is Pandas. And Pandas is used for what we call data analysis. Pandas is an idea of this data frame, which allows us the functionality
I'm going to learn Pandas here. Wow.
In tabular structure with rows and columns. That is, you get to usually read a CSV file using Pandas. It's going to extract this data into something called data frame, and you can do all these amazing transformations and aggregations using these data frames. And don't worry, I'll show you how to do this in the next video. So we have NumPy for working with lists and arrays, Pandas for usually working with something like tabular data, so CSV files, and then we have Scikit Learn. And Scikit Learn is that really exciting create a model part, where we import the Scikit library, and Scikit comes pre-built with, as you can see, different algorithms that we can use. So we can do classification, we can do regressions, we can do clustering, just by importing this library. We use something like Matplotlib.
Oh my God, those are a lot of
again, is another library, what we call a
libraries.
library. It allows us to visualize data in a nice way. And there's many tools that are built on top of Matplotlib that help us visualize data in any different way that we want. Finally, the 2 last crucial tools that we need is, first of all, Jupyter Notebooks. If you remember, in the developer environment section,
way back,
Anaconda, and how Anaconda, by installing it, gives us access to the Jupyter Notebooks. And Jupyter Notebooks are really, really useful because up until now, we've written code in PyCharm or Sublime Text or Visual Studio Code. But Jupyter Notebooks are really, really useful when we do machine learning or data science because, as we'll see, it allows us to step through our code and actually output and keep track of all these things that we've been doing. And also see visualization. Something that you can't really do in a text editor like Sublime Text or So you can step through each data analysis stage and have these notebooks visualized and potentially even give to different people in your company so that you can create a story and share it with others. So it's a notebook that allows us to communicate better. And it's a very critical tool that is pretty much standard now in the data science and machine learning field. And as you can see, these are crucial tools in our toolkit that we're going to use throughout the next couple of videos. But all of them work really, really well with Python. And it's why Python has become such a standard in the machine learning community. The final piece of the puzzle, though, is that data, right? When we import the data and clean the data, we talked about the most difficult part being the actual collection of the data. In order for us to learn about machine learning, we actually need some data to work with. Now, we're not Facebook or Amazon or Google or Apple, but there's another useful tool called Kaggle. And Kaggle is a community of machine learning experts where you can do competitions, you can look at other people's Jupyter notebooks, but it also has data sets. That is, we have free access to data, to massive amounts of data that are openly accessible. If you want to learn about crimes in Boston, about the PGA Tour, about gas prices in Brazil, you can actually download for free these data sets so that you can play around with machine learning. And we're going to do just that in the next video. So for now, make sure, if you haven't, get your Jupyter notebooks ready. Again, check the developer environment section where I show you how to set this up, and then create a free account on Kaggle because we're going to start getting our hands dirty with some coding. I'll see you next time. Bye.
Okay, interesting. Looks like
It's time to finally start coding.
Coding. Wow.
We're going to be exploring some data that we're going to grab from Kaggle. It's time to do some coding. So open up your Jupyter notebooks. Now, in my case, I already have some files here, but usually it'll just be whatever files you have on your desktop. It doesn't really matter because we're going to create a new file here and make sure that the notebook is going to be in Python 3. So once you create that notebook, title it whatever you want. In our case, we're going to be exploring some FIFA soccer data sets. So let's just call it soccer. Now, in order for us to learn about data science and machine learning, we remember our steps, right? We have to import the data. So we get the data from what we explored last time, which is Kaggle. If you haven't registered already, make sure you do that. Otherwise, just sign in. And once you're signed in, just go to datasets. Let's make this a little bit bigger. And within the datasets, again, we can pick whatever we want, but I feel like checking out the FIFA 2019 dataset. Now, I usually like looking at the scores here to make sure that it's a good dataset. In this case, it looks like the FIFA 19 complete player dataset is looking pretty nice. We have 2 megabytes of data. It was uploaded 8 months ago.
Whoa.
And it's a one file CSV file. So you can actually click on
2 megabytes.
and it'll show you some other information that you
of CSV.
file. So that's great, but just a heads up, it is a bit of a big dataset.
Whoa, yeah.
So if we click on it,
that's a lot.
we can just simply
2 megabytes may not seem like a lot
your datasets gets downloaded.
considering the size of videos, but
where your Jupyter.
oh, it's zipped.
So you want it in the same folder as
Oh
the
my God.
notebook that you just created.
But as text files, 2 megabytes is way too much.
So now if I go to my home, I see that I have data.csv, which is the file that we imported from Kaggle. As you can see right now, it looks like a massive amount of data. We can't really read it because it's in CSV format. Now, if we go back to our soccer notebook, we're going to use the Pandas library to do our data analysis to see what we actually got from Kaggle. Now, in our case, we used Kaggle to grab our data, but you can imagine that there's different ways to gather the data. You can, for example, like we saw, use something like Beautiful Soup to scrape web pages so that you can understand it better. So you can use any type of data possible. Ideally, if it's in a CSV format, then we can use Pandas and really do some neat things with it. So let's take a look. Now, luckily for us, by opening Jupyter with Anaconda, remember the Anaconda navigator, we actually have access to libraries like Pandas automatically. So all we have to do is simply say import Pandas, and we can do as PD just so we have a shorthand instead of typing out Pandas every time. So to do this, I now have access to Pandas, and with Pandas, I can do read_CSV to actually read our CSV file. And because our CSV file is in the same folder as our soccer notebook, I can just simply give it the string data.csv, which is what we have over here downloaded. So if I run this, I get my data right here.
Ah, you can see it there. Okay, I guess.
With nationality, we have links to photos, we have the name of the players, the IDs, the age, and a ton of other things.
Yes,
now,
tabular data.
Is that we get this output as what we call a data frame. And Pandas allows us to manipulate this data frame so that we can do interesting things with it. So usually what you'll see is you'll just create a variable, data frame equals pd.readcsv.
Oh, okay.
So that now this data frame is what we get down here. All this information is now in our data frame.
Okay.
And we can do interesting things and run different methods and properties on it. So for example, if I do data_frame.shape, it'll give me more information about my data. In this case, you'll see that a tuple object is not callable. I get nice errors in my Jupyter notebook. And that's because shape is actually not a method, but instead a property on data frame.
Oh, it's a tuple.
This is the shape of my data.
What does that mean?
9 columns and, well, a ton of rows.
Oh, okay.
Now, I can also do different things. And this is the neat part about Jupyter, is that I can just leave the input and output here. And if I do a different cell block, I'll still have this information. It'll still have imported
These rows and columns. Okay.
So if I do now data frame dot, let's do describe, I'll be able to run this. And again, it shows or describes the data that I have.
Okay.
In describe, we get the count. So for example, the overall age accumulated, we get the mean age, that is the average age of the player, so 25.
Oh.
We also get interesting things like maybe the oldest player.
So that's just
the highest jersey number.
That's statistical information about this data set. Okay.
Finally, if I do something like data frame
standard,
and I run this,
50%.
I get all the values of my data. And you see here that it's an array that has different players in it. So remember how I said libraries like NumPy work with arrays and lists in Python and help us manipulate them? Well, as you can see, our data frame is stored as an array of each individual player that we could potentially manipulate.
Okay.
And what we've done here is we've simply imported the data. So we learned the first step of our ML steps. That is to import the data. We found the data and we used Pandas to grab our data into a data frame. Now, there are many different things that you can do with Pandas. And I want you to, after this video, I'm going to link to this resource so you can try different methods and properties on your data frames to see what type of things we can do. So I want you to go through this exercise and just try different things. For example, in filtering here, we can try and learn about filtering our data frame. So again, if I just copy and paste this, change this to our variable that we have. So data frame.
No more coffee.
And then we want to filter. Let's look at the shape of our data or see what type of data we have. You know what? Let's filter by age. So I'm going to say data frame. We're going to go by age. And I'm going to say age is going to be older than, let's do 40. If I run this, and age should be capitalized here. So I got it here. If I run this again, there we go. I got,
whoa, not many.
Just the first couple
just 5
of
people.
players with age over 40. And I was able to do that
41. Oh my God.
And learning about filtering. So I want you to explore this, it's not too long, and try out different data manipulation techniques so that you get familiar with Pandas. Again, you don't need to memorize this. Often, usually, we'll just look at the documentation and grab the data that you need. In the next video, we're going to try and solve an interesting problem with this data set. I'll see you in the next one. Bye-bye.
Okay, I think I'm going to leave it as is for 2 reasons. I'm going to stop this. I may like to rewatch some of these videos because I don't have installed Jupyter notebooks. I don't have that, so I'm not going to be able to follow the coding examples. So I may like to step back a little bit. I'm going to be doing that tomorrow. I'm going to use this opportunity to move into learning data warehousing, and that's required for a new position I'm looking forward to. So, okay, so thank you for coming in if you indeed are, and see you right now because I'm going to switch back